Hello and welcome to the KDE Direct Design Engineering episode 12 now. My name is Patrick Koegler. I am the owner and lead designer for KDE Direct. And I'm here today to talk to you about our new ESC technology. So we're in our 8th year of business now, so thank you everyone for all your support, companies, clients. We are definitely here for you in the United States, and we enjoy every minute of what we're doing. So what I want to talk to you about is we just released, and for those of you who've already seen it, our new series of electronic speed controls. These are termed the HVC series, and I'll start off by talking about the 95 in more detail for you as we go along. So the whole point of this discussion is to show you the new technology within these magic black boxes here. Some of the new algorithms, including synchronous rectification, that is ideal for multi-rotor applications. It also applies to radio-controlled helicopter applications, especially in the governor mode, and I'll go into why some of the details of that are so beneficial for flight performance. So without further ado, we'll go into more details. I'll show you this actually operating on the dyno. We have a small dyno in this facility here, and I will show you how the different settings that you can program in this relate to your flight performance. Also brand new for us in, let's see, we're in Q3 of 2015, is our Propeller series. We went along the route of folding blade propellers. These are the 27.5-inch designs. And I'll also have another design engineering episode for you to go into more details of these. The goal here was to bring essentially the highest quality propeller and engineered airfoil that we could bring to market, and we couldn't be happier with the way these turned out. We offer them in both dual and triple format. This right here is our 18.5 version, and as you can see, they can fold out nicely for flight, and then when you land, you can fold them up nicely on your system. You don't have to unbolt them from your motors in order for easy storage and portability. So very cool stuff, and we'll go into more details. Okay, so coming into 2015, we will be expanding this line more, but I wanted to give you an overview of the current electronic speed controllers that we offer on the market. We offer a wide variety of sizes, starting with our 20 amp LV. Now this is very popular for FPV racers and also lightweight quadcopters. You can run up to about a 2814 size motor on these, and this is capable up to 6S. So that's the big deal in racing. 4S to 6S racers, they're just insanely fast, lightweight. We also have a foam backing so that you're protecting the electronics during flight, and they're designed for just great durability. We also have the ability to program these, and I'll go into more detail later. Next size up is our 35 and 55 series. They are 8S capable, so you can go all the way up to 35 volts on these, and again, they have all the same features of the much larger versions. And new for this year as well is we not only have the cable for connecting to your flight controller or receiver, but we also have a dedicated programming cable now. The nice thing about the programming cable is you do not need to arm the ESC in order to program this with your computer. It's very cool. It auto turns on the microprocessor inside this unit, and so you can program everything safely. This is a historic version, our 75 HV. There's still many out there. They're a great unit, and they go all the way up to 12S. And so what's being replaced for this unit this year is our new all aluminum case editions. So we have a 75 and also a 95 amp edition. The great thing about this, it's an all aluminum case, CNC machined, extra awesome cooling. So basically this works as one giant heat sink, as well as rugged. So, you know, it's totally encased inside. Again, you have the programming lead, and you also can operate this on 12S. The capacitors are actually supported by a specialized rubber grommet that's molded to this. So the capacitors are fully supported. There's no chance of these breaking loose, helping protect against damage. as well as the motor exit leads. So the exit leads also have a rubber gasket, and then there is a clear epoxy layer put on the front. So not only are we relieving any stress to the solder joints internally, but also waterproofing. So while the ESCs cannot be 100% dunked into a bucket of water, any type of weather conditions they're fully capable in. It's very difficult for any moisture to get inside of these. They're fully sealed and closed, and overall just the performance of these is just fantastic. So they've been very popular in the commercial industrial segment, where they wanted something much more durable than a heat shrink case. Heat shrink case is nice for keeping things light, but when you get into more rugged applications where these are going to be used daily in all types of weather conditions, and also ruggedness, whether they're dropped or you experience a crash or just rough environment, a lot of times these are going to make it through and you have no problem. So again, these are 12S capable, and 95 is our new flagship edition, and can go all the way up for a triple setup on a 27.5-inch propeller, which I'll go into, which is an incredible amount of thrust. So the other few things on this table I just want to show you. Here is what we call the device manager adapter. Now this is the programming unit, so it's a low-cost unit. When you open this up, inside we also have a card for you telling you to go ahead directly to our website, and you can download the software that you can install to your PC for programming. And then from there, inside here in the ESD bag is the actual programming unit. It's a small little USB to 3-wire pin programmer. And all you do is you plug it in. There's even alignment that tells you which wire goes where. And then your mini USB cable. So this can plug into any standard PC, Macintosh, Mac, anything like that. And you can program these now and adjust various settings for you. And not only programming, the biggest benefit is for the lifetime of the product, we offer free firmware upgrades. So as the technology continues to expand in this, not only in amperage capabilities, but also in technologies to help cooling, multi-rotor performance, faster synchronization to the flight controller, you can go ahead and update firmware directly off our website and bring all of your latest products up to date. So very cool. So whether you have one that's a year old or so, you can always update it up to the latest production code and be running some of the latest technologies that we can introduce. And these are all this is our largest, this is our 7215 flagship motor. So this is our heaviest lift motor that we use for commercial environments in an industry. These can put out an incredible amount of thrust. To the lighter high efficiency 12S version, this is our 7208, very popular for long duration flying. Can run anywhere from 6S to 12S, and you're going to get some incredible efficiency out of these. As well as, here's a sneak peek to a new upcoming motor that we're releasing called the 4213. It's a 360 kV 28 pole design. This is designed purely for high efficiency and smoothness. Very low cogging to the motor, and not only that, it's extremely efficient. We've been able to beat the performance of some of our other highest efficiency motors. So look for these. These will be coming out in the next few weeks. So from here, let's go into some of the new technologies inside the ESCs, and I'll show you actually with the motor running just how fast and how accurately these motors will respond to your flight controller. So before we go into the full dyno, the first thing that we find the most important thing is throttle resolution. So how accurately it's going to trace the throttle commands, and also to make sure that your throttle is 100% smooth from 0 to 100% full throttle. You don't want any dead zones, lags, places where the motor loses commutation, because obviously during flight, your flight controller is not going to have control during those time periods. So what I'm going to show you here, I just have direct control of my radio, and I'll show you, this is just starting up the motor, and what you want to see is as we go up in throttle, this nice smooth transition all the way up. And as you can see, It's 100% smooth all the way through the transition. There's full throttle, and we'll go all the way back down. The motor can just hang there smooth as butter. And you won't see this with any competitive offerings because it's very difficult to have 100% resolution to the motor from your speed control. So starting with that is the core basis of a good control setup and a motor optimization. A lot of the times you'll hear us talk about motor and ESC optimizations, and there is a lot of science that goes in there. You want to make sure that your ESC is talking 100% pure commutation to the motor. You don't want any commutation failures, any chance of areas where the motor kind of gets rough or runs really rough or noisy. You want it nice and smooth throughout the whole throttle control. So from there, we'll switch to the dyno, and I'll show you some of the new technologies. Look of our basic dyno. Now this is done just for propeller data collection as well as testing. What I have here is a power supply line. I'm coming in, it's at 25 volts to our 75 HVC ESC. Now it's connected to a 5215 435 kV motor with our 18-inch propellers connected. So this is in the dual format, and this is a very high power, high heavy capacity system. Now we also have up here, if we want to turn that on, is our digital thrust gauge. So this is a very accurate unit, been very happy with this, and we can measure down to 10 grams of thrust on a linear guide. So as this motor pulls, it's going to pull against this, and you're going to see the numbers go up. So from there, what I have it connected to is a Futaba direct receiver to my radio. So I have direct throttle control. I can start the motor at will, and I also have full control of the throttle. So what I'm going to show you here is I have what's called synchronous rectification currently disabled. Synchronous rectification is an awesome technology. It's also referred to in some categories as active freewheeling, although we do it slightly different. And in this regard, what we're doing is right now we have that disabled. So the only way to control the deceleration of the motor, and this is a very typical ESC that you would see on the market that do not support active freewheeling or synchronous rectification, is that you have full control of the acceleration, but deceleration of the propellers is purely by the drag of the system. So you start to get into wind conditions or something like that, the flight controller cannot control that, and you lose some flight stability. You'll see what's called the feeling of floating during flight. So I'll show you the startup here, and you'll see it's nice and smooth, and also how fast reaction our throttle is. So if I can get a better view here, it's as fast as a servo. It's very amazing how fast it can react to the motor. So our ESCs can go all the way up to 600 hertz, and they also auto-tune to the flight controller. So if you're running a DJI system that's 400 hertz, it's going to lock into 400 hertz, and you're not going to have any commutation problems. And so, as you can see, it's very fast. I can't even move my fingers fast enough to change the reaction of the motor. So one thing you're going to see right now is when we have synchronous rectification turned off, when we want to quickly decelerate, you can see it's slow. It'll go up, and you can see the propeller has to wind down. And there we go, we'll drop down. And you can see it takes a few seconds, it takes a little bit of a lag for the propeller to stop. Now this will change once we enable synchronous rectification. Let me turn that on, and I'm going to show you what a cool effect this is. So I've gone ahead and enabled synchronous rectification in the ESC. That's one of the settings for you with the device manager. And all the ESCs now are shipped with synchronous rectification enabled. So very few times do you even have to use a programmer anymore. They're all plug and play when they just get received at your location. So what I wanted to show here was here's the power supply. And on the right side is voltage. So we'll turn this down to, we'll get it close or up to, let's see, there's 25, we'll get it right at 25 volts. Okay, so synchronous rectification, what it does is in order to decelerate the motor, it actually uses regenerative braking, meaning it's going to push power it's going to take the power out of the rotor head and move it back into the battery pack. It's very awesome for regenerative braking in that you're going to gain flight efficiency because you're not trying to dump that extra power off as heat as a traditional ESC, and rather you're going to recycle it through the system. Not only that, but during standard partial loading, you're also recycling the energy through the MOSFETs and back to the motor. So overall, your ESCs are going to run much cooler and you're going to have much higher efficiencies across the board on your power system. So one of the things I'll show you here is the actual motion of the power going back to the system. So when I start up the propellers and I'm going up to speed, when I pull back, you're going to see a sudden jump in the voltage, and that's the power trying to get pushed back to the battery. You can see how those numbers are changing. 27, 29, and the power supply doesn't really like that very much. It's hitting the capacitors of the power supply, and it's not good for it. So I don't recommend this for anything. I just wanted to show you the effect. So for the actual showing of the technology, the best thing to do is use a LiPo battery, because the LiPo battery not only can absorb but also give out the power that it needs. So I'm going to switch to the battery and I'll show you how this operates. It's connected from the power supply and I've connected to a large battery. This is a 6S 22000, great battery, and again, same system, same everything. I'll turn the light on so you can see that. But what I'm going to show you is the actual effect. So one of the technologies we have is a dynamic startup. So it's going to sense the motor and then start it up nice and smooth for you. And there you go, it's ready to go. No hesitations, and you're just ready to fly every time. You don't have to worry about starting up KDE Direct motors. So from here, as we go up, it'll actually enable synchronous rectification at a certain RPM. So as you go up, you can go to full throttle, but what you're gonna hear is a distinct difference in how fast it can react to the propeller and also cause active braking, it's called. So as we go up, let me see if I can get a better view here for you. We'll go to full power. You can hear it braking. See how fast that propeller is going to, it's a direct control. Not only can I also control the acceleration, but I have direct control of braking. And as you can imagine, that completely changes the dynamics of your flight controller. So, again, it's very fast. And you can go to full throttle just instantaneously. See how fast that is? I mean, there is no lag in the KDE system. So we wanted to make these as fast and accurate as possible, and also to have direct control of the throttle. And you can see just how fast. See how fast it's going to chase that throttle? And again, to go to full power, it's instantaneous. There is no lag. So that is the core of the new technology. Your motor and ESC and flight controller now have a direct connection to each other. Very fast, very accurate. ESC is not even warm. I can put my hand on it. I mean, any other ESC pushing that kind of power on an 18-inch propeller, you're going to get hot. You're going to get burnt. It doesn't even feel warm. And so for a long duration flight, you're good to go. This is very efficient. You're going to be having recyclative energy going on, so you're not burning off what is called that braking or that freewheeling effect. You're not dumping that off into resistance as heat. You're actually recycling it back through the power system. Much more effective. Excellent for multi-rotors because of that active braking phenomenon, which is excellent. You have direct control, and whenever you need to go, you can just go. So that is the core of the new technology. Some of the other technologies in here, they are temperature controlled. So depending, you can change the level of synchronous rectification in your system. So depending on the temperature level, it's going to auto adjust that. We revamped the dynamic timing algorithm for this, so it actually changes the timing and PWM rates depending on what motor it's going to sense in the system, as well as one very cool effect that people enjoy is what we call active anti-spark. So traditional ESCs, when you plug them in, you'll get that big spark at the end of your connector, which is not only kind of shocking, especially on a big octo setup, but also damages the gold-plated bullet connectors of your system, which is not good. You don't want corrosion there. So these actually implement an active anti-spark. There's a circuitry inside that actually slowly enables the power to come in and charge the capacitors, and you don't get that big spark. So as I can show you here, when I plug in, nothing happens. You know, there's no spark. Now the system is arming, and we're ready to go. So it charges up the system, the microprocessor has full control of that, and then once it knows the capacitors are charged, it's going to enable arming, and then you have full control. So very cool, and I hope you guys enjoy it. And that is the core of the new ESC technology. So please feel free to email me if you have any questions at sales@kdedirect.com, and we'll get you taken care of. Thanks again.